Hello everyone, myself Nilesh Phapale and me with my team are going to present you on the topic of transforming an image into a pencil sketch. So in this presentation, we are going to show how we can take an input image and applying some image processing techniques, how can we convert it into a pencil sketch. The input image could be RGB or a grayscale and we can still perform operations and convert it into its grayscale. So let's I would like to introduce to our team members. So first myself Nilesh Phapale, then Gunal Gupta, Ved Vekhande and Govind Garg. So let's see how can we do that. So there are three main steps that we need to follow in order to transform the image into its pencil sketch. So first is the line drawing. Let's imagine that we are drawing a pencil sketch on a paper using a pencil obviously, and so in that step we first find out which objects we want to draw. First let's imagine that we are drawing a human. So first thing that we'll do is draw the outlines of that human. So similarly, if we have an image of a human and we want to convert it into a pencil sketch, what we can do is find out the edges, so that the edges will be similar to lines for the pencil sketch, and we're going to see how we can find out the lines or the edges later on. Then after we have find out the edges, then comes the part of drawing. So tone is like the darkness and the brightness, which parts has to be darker and how much darker, which part has to be lighter and how much lighter. So if you are drawing using our hand, um, for darker part we use a pencil much more often in that portion, and for lighter or brighter parts we don't use that pencil, we don't use pencil that much. We just keep that part as it is, because the paper itself is white, so we don't need to do that. So similarly we have to perform some operations on the image to get its tone map, and after we have got the tone map and the lines, to give it more natural feel we need to also add some texture, because in natural pencil sketches the texture is added due to the interaction of pencil and the paper. So we are also going to have that texture rendering part in our process. So now I want all of you to focus on this image, because all of the later in the presentation we are going to perform the operations on this image. So this is the image of Messi lifting the FIFA World Cup trophy in the 2020 World Cup final. So now let's move. So first is the line drawing. Obviously, as I earlier said, in order to draw the lines, we need to find out the edges, because edges will similar to the lines. So we have used the first order derivative, which is the gradient method, to find out the edges. So the equation of gradient image G is given as the partial derivative of I in x direction square plus partial derivative of y in y direction square, and just the square root of whole, where I is the grayscale image. So we first need to take an image and convert into a grayscale to find out the edges. But we cannot use just the gradient in order to convert. We cannot just use the gradient for the line drawing, because gradient is not generally what to say, is not generally continuous. The edges will not be continuous. So but we want continuous lines, we want lines to be continuous, so we cannot use gradient. So we propose another method, which is to generate a response map. So response map will show in which directions pixels are oriented, or in which direction pixels line up. So that is calculated by GI, which is the response map in ith direction, and it is calculated by convoluting the gradient G with Li. So Li is a line in the ith direction. So we totally have 8 directions, and all the directions are separated by 22.5 degrees. So you can imagine a plane, a 360-degree entire plane, which is divided into 8 different lines, which are equally spaced apart, which are also passing through origin. And after that we perform the classification. So our main goal was to classify our gradient G into 8 different parts, or into 8 different directions, so that we could identify which pixel is dominant in which direction. So we perform the classification, So what we do, we take a pixel and check its response map in all the eight direction. And if the pixel is dominant in that direction, that means if it has the maximum value in the response map in the particular direction, we classify it into the I direction. So it is given by the equation CIP is equal to GP if arc maximum I of GIP is equal to I. That means if the pixel is has a maximum value in the ith direction, then it is classified into CIP. Otherwise the value is said to be 0. After we have classified our graded image into 8 different directions, the next thing we perform is generating the pencil stroke. Uh, that is find out by the summation of Ci convolution of convolution Li. So the star symbol actually indicates the convolution. Uh, so Ci is the classification in the R direction and Li is the line in the R direction, and we sum up the result to get our S prime. S prime is not a perfect pencil stroke, because in S prime we will have background as black and the lines as white, that we don't really want. We want our lines to be black and background to be white. So we need to inverse s prime, so that we will get our s, and also s prime is going to have values which are beyond 0 to 1. We will keep values between 0 to 1 so that our computation is easier. So first we need to normalize s prime between 0 to 1 and then inverse it, so that we will get our actual pencil drawing. Now let's yes, yes, and this in this diagram. So here we have in the top left corner we have a gradient, and then we can see that there are 8 different classifications. So the gradient is divided into 8 different parts with respect to its line, and then we perform the convolution of the classified image with respect to its line, and then sum the results up, inverse, and then we get our pencil drawing. So let's see this on our messy image. So this is the line drawing of the messy image. It's also called a stroke map because we have some dense stroke, we have some lighter stroke, and all of this perform, we get this result as the line drawings. Now from this point onwards, I would invite my team members to carry on.
So thank you, Nilesh. And hello everyone. My name is Kunal. So let's start with the concept of a tone map. As we can see, the tone distribution of a grayscale image differs from that of a colored one. Our goal is to find a targeted tone distribution, which is represented by the equation provided. The equation is a summation of the product of weights and function of x. The graph visually illustrates this concept, providing a clear understanding of how tones are distributed in different types of images. So let's move to the next slide. So yeah, next we delve into the distribution of tone layers. We apply a normal distribution in this dark tone layer. As shown by the equation on the slide, this equation represents a probability density function of a normal distribution. But what about the controlling parameters of this distribution? This is a crucial question that we need to explore further. We also discuss the concept of embellishment for the mid-tone region, which is represented by another equation. Yeah. So the next slide is parameter learning. Parameter learning is a key aspect of our study. We manually initialize target and dark tone layers with thresholds at extremities, iterating peaks until no change is noted. This iterative process is crucial for refining our results. The parameters are estimated by using maximum likelihood estimation, aka MLE method, a popular method for estimating parameters in statistics. The details of this process are shown in table 1. Now, from at this point, I would like to invite my other team member, Ved, to carry on from the next slide.
Thank you, Guran. So finally, now we perform the histogram matching of the input images. So just to have an idea, what is histogram matching? So basically, it is transformation of an image. So its histogram matches the reference image. So we have a particular image, and we have to match its particular histogram with reference to an images whose histogram has already been performed. So what is the main goal of histogram matching? So it takes an input image and generates an output image that is based upon the shape of the specific histogram. So just to have an slight description of how to do histogram matching. So at first we equalize the histograms for both the images, the input image as well as the reference image, and then we equalize the histograms by drawing its particular tables. So for the first image, we consider the two particular columns, the round off column and the new NK column. And for second image, we consider gray level and round off column. So while histogram matching, we match it via round off columns. So next we get the toned image for this particular histogram. So just to have an idea of what is toned image, so it converts HDR images. HDR stands for high dynamic range images into images suitable for display, or rather images that are suitable to print on a particular paper or rather in poster. So here we get the toned image for the input image that we had previously. The next we have is pencil texture rendering. So this technique is used to create realistic textures in graphic design and art. So the very initial process involves repeatedly drawing at the same place to generate tonal pencil texture, which is then layered to achieve depth and texture. This is done in a digital context, obviously, but this technique is very similar to the traditional sketching, where an physical pencil is involved for sketching. So the mathematical aspect can be seen on the screen. So the main equation that we have is h of x is equal to j of x. So here to have an idea of what this particular term stands for is, uh, so just we use it to minimize the difference between the drawing patterns. The drawing patterns here are represented by h, and the toned map, which is here represented by j. The value of beta, which is adjusted to achieve this. So the final equation that we have is this particular equation, that is beta star is argument of mean and then the rest of the equation. So in this particular case, we have considered lambda uh, with a weight value of 0.2. The main reason behind doing this is balancing the optimization problem we are solving over here. So this complex equation can be efficiently solved using conjugate graduate methods. Uh, what is conjugate graduate gradient methods in this case? So it's just a numerical algorithm that quickly converges to a solution. Finally, the pencil texture map T, which is here, is computed through an exponential operation, which is given over here. That is T is equal to h to the power of b star. So the final step transforms the initial drawing patterns with optimized tonal variations, resulting from the calculated value of beta, which was calculated right over here. And in essence, with this, each stroke and tone is mathematically calculated and rendered for precision, ensuring that the digital art not only imitates but also elevates traditional pencil texture and techniques. So we have got this particular image after getting and solving the equations that we had. So this is the image for pencil textures. Next, we have an post processing, which is a final pencil sketch that can be obtained by this particular equation, which is right on your screen. That is R is equal to S dot T. So here, what is R, S, and T? So S here stands for pencil strokes, and T stands for tonal texture. Yeah. Next, this is the final image that we get after rendering all the processes and post-processing our toned image. Next, I would like to call Govind to continue the presentation. Thank you.
Hello there, it's Govind Garg this side. Now let's talk about how to impose color on the sketch. Now to impose color on the sketch, we will use the pencil sketch R. This pencil sketch R is formed in the first two steps shown here. The RGB format of the original digital image is converted into the YUV space, and now the Y channel of this YUV space used to generate the R pencil sketch. Now this R pencil sketch is use again to generate YUV space in the step third, and in step four this YUV step generated back the RGB format for the colored sketch. Now this is how the color sketches looks like after the RGB format is imposed back again. Now moving forward, let's compare some results. Now this result is obtained after imposing the weight of tones according to the value shown in the table 1 earlier. Now here you can see in the third point the stones as is comes on the face of Messi. Now let's move on to the next results. Here you can see the clear difference in the step third in the tones. Here we use the weighted tones 2, 22 and 76. Now if I take you back again, you will notice the color difference properly. Now let's move on to this pencil sketch with different textures. Here we use three textures to show the different kind of result we will obtain on obtaining using them. The first one is a little rough, third one is more rougher, and the second one is of line width. So the difference is clear. Moving on, what we improved. Now, what we have improved on the basic proposed model, we have imposed the deionizing the input image using Gaussian filters. The Gaussian filter deionize the input image, and furthermore, we use the 22.5 degree strokes instead of 45 ones. Now, acknowledgement. We would like to acknowledge Dr. Jignesh Patel, our assistant professor, for giving us this opportunity and make us explore the field of image and video processing. Now, reference. This is the paper we used for our project. It was published in 2012. Thank you.